Lasers were developed. The idea was, well, let's replace an infrared beam with a laser beam because it's much smaller, far more intense with a ruby laser, but because it's in effect light, you can modulate the beam to pick up speech.
Dr. Martin Simon is a laser specialist working at UCLA.
What we have here is a setup that will show us how you can carry sound waves by modulating the amplitude of the sound wave, that is the intensity of the light. We'll turn on the laser, and I'll follow the beam back. And the beam is terminating on a photocell, which we're using as a detector of the intensity of the light. The photocell output then goes into this amplifier, an audio amplifier, and into an audio speaker, and we're going to see if we can convert it back, the light intensity, to sound. So I'm turning up the amplifier. If we have the beam in there, we should be able to find it, and if I then block the beam and turn it on and off, we should be able to hear the change of intensity at the detector. Okay, now we're going to modulate the laser light with sound played from this cassette recorder. So now we have the sound coming through the light beam and being demodulated and picked up. If I break the beam, the sound goes away.
What the problem was, though, operationally, is when you would send a laser beam 100 yards, 200 yards, a half mile against a window, the light beam would bounce off just like a pool ball does when it hits the bumper. So one of the only effective ways was to try to be directly hitting the window straight on so you'd get a reflection back to you. Well, this was a limitation. But a very, very clever Western scientist remembered the principles of a prism.
Scientists found that the distinct shape of a prism allows a laser beam to be reflected in specific locations.
What we have here is a prism out of plastic. In normal cases, light will go right through a piece of plastic like this. You can see it traveling there. But if the angle is steep enough, all the light gets reflected inside the plastic and comes back, so that this prism is now acting like a mirror. If the prism was on a window and picking up vibrations of the window, say caused by someone speaking inside the room and vibrating the window, then the laser beam would then be modulated by the sound waves of the people in the room.
American intelligence soon installed a miniature version of the prism inside a glass window destined for the Soviet embassy.
You could be at an angle and shoot a laser beam at the window, but because of the prism, you'd hit the flat surface of the prism and you would reflect the signal back. So this eliminated the need to be directly dead on to a window. When the Soviet Union discovered the first window and saw this little miniature prism inside, it was difficult for them to understand what it was until they took the opportunity to hit it with a laser and saw exactly the reflective properties.
This capability forced intelligence services to rethink the way they constructed their own buildings.
When the CIA, for example, built the new headquarters building, it is literally a building built within an outer shell. And its purpose is that if a laser beam strikes the outer shell, it'll pick up nothing, because there is a airspace between them in which they can pipe music or just vibration, and it's specifically designed to eliminate refracted conversation recovery from a laser.